Now in this example, we have to evaluate the definite integral of x square from the limits 0 to 1 as a limit of sum. So as we have seen how to calculate a definite integral using the concept of limit of a sum. So first of all, let us write down the symbols, that is the function that we are talking about here is the x square. The lower limit a is 0, upper limit b is 1, correct? Now if you observe, in the original process we have b is equal to a plus nh, isn't it? Because we are dividing it into the n equal parts having the width of h each. So here in this case we will write b, that is 1, is equal to 0 plus nh because a is 0. So basically that gives us 1 is equal to nh. So here we have got one important relation between n and h which will be used while we evaluate the limit. Right. So keeping that aside, now let us start off with the integral. Let us denote it as say I. As per the formula, it is limit of h into summation of f of a plus rh, where r varies from 1 to n, and we take the limit as n tends to infinity, isn't it? So that is equal to limit n tends to infinity h summation of f of, now here a is 0, so therefore we are left with just f of rh, and r varies from 1 to n. So moving ahead, we have limit n tends to infinity h summation of, now what is f of rh? For that, let us understand that the function is given as a square function. So f of x is x square, so therefore f of rh must be rh the whole square, which is nothing but r square h square, where r varies from 1 to n. Now moving further, we have limit n tends to infinity h. Now if you see in the summation, it is r which is the variable counter. So r is taking the values from 1 to n. So therefore from the perspective of r, h will be treated as constant. So therefore we can take h square term outside the summation. So therefore h square taken outside, there is already one h, so that gives us h cube finally, and we have the summation of the r square term as r varies from 1 to n. So what is the meaning of this summation? We want to sum the squares of first n natural numbers, and from the sequences and series we already know that this is a standard result. So let us write that result, where we are n tends to infinity, we have h cube, and summation is nothing but n into n plus 1 into 2n plus 1 whole upon 6, which is a standard result. Sum of squares of first n natural numbers is given by this formula. Alright, now what do is, we have to keep in mind we are evaluating the limit in which the variable n is tending to infinity. So somehow we have to adjust the different powers of n in the denominator, right? Okay. Now if you observe this h cube and n, suppose I write it as h square into h into n, right? So out of which nh or hn can be replaced with 1, because that is what we had found out already. So since nh is equal to 1, replacing that with 1, we are left with just h square upon 6 into n plus 1 into 2n plus 1. Of course, we can take 1 by 6 outside the limit because it is a pure constant. So here we have limit of so limit as n tends to infinity. Now you see this h square can be written as 1 upon n square, because once again, since hn is equal to 1, h can be replaced as 1 upon n. So therefore I can write it as 1 upon n square multiplied by, as we already have, n plus 1 into 2n plus 1. So that is equal to 1 by 6 limit n tends to infinity. Alright, now here what do we do is, one of the n we give under this bracket and the remaining n we give to the second bracket. So n plus 1 upon n gives us 1 plus 1 upon n in the first bracket, whereas in the second bracket, after simplifying, we will get 2 plus 1 upon n. And now it is clear that if n tends to infinity, then both of the terms 1 upon n in the two brackets will vanish, that is, they will eventually become 0. So what we will be left with is 1 upon 6 multiplied by 1 into 2, so that is 2, which gives us the answer as 1 upon 3. So that is the value of this particular integral.